Bismillahirrahmanirrahim. Welcome to this lecture, which is about the arc length of a curve. In this part, we are going to speak about how to find arc length of a given function or of a given curve. As we did before for finding the area, we can estimate the length of the curve. And to estimate the length of the curve, we can partition the interval between A and B into small partition or subintervals, x1, x2, x up to x sub n, and we connect between the two, any 2 points by a straight line. Let's say B0 and B1 is a straight line. So we can find the length of this segment. We know that the distance between 2 points, we can say the absolute value of B2 minus B1 is given by delta x square plus delta y square. I can say delta xi and delta yi square. If we do this for all the partitions or for all the line segments, we can estimate the arc length by adding all of these distances. So we can say the arc length will be equal to sigma of all of these bi plus 1 minus bi. Or we can say it is equal to sigma of all these delta xi square plus delta yi square, assuming that all these delta are equal, the same. So the arc length for the given curve for this function y equal to f of x can be estimated by sigma of the sum of all of these line segments, or the length of these line segments. And if we make this partition very small by taking the limit as n goes to infinity, then we can say this is equal to the limit, or sigma. I can take the limit inside, square root of delta xi square plus delta yi square as n goes to infinity. But this can be done as limit. I will divide by delta x square. I will have 1 plus delta y over delta x I all square, which can be written also as sigma. I will take this delta x outside, and since n goes to infinity, this is n, I will have limit of delta x multiplied by, let me write it as delta x at the end, it is 1 plus delta y over delta x square multiplied by delta x. But as x or as n goes to infinity, this means that delta x will go to 0. Which means this can be written as integration. Limit as delta y over delta x as delta x goes to 0. This part is the derivative of the function. This is derivative y prime. So we can say the arc length can be written as integration from a to b of square root of 1 plus y prime square dx. Or we can write it formally. The arc length for a given function, if f prime is continuous on the interval a, b, then the length of the curve y equal f of x by x is between a and b is given by m equal to integration of the function a or square root of 1 plus f prime square dx. And the limits are a and b. So this is the formula for the arc length. It is integration or definite integral a to b square root of 1 plus f prime x square dx. As a direct application for this formula. Let's find, or let's use the arc length formula to find the length of the curve y equal square root of 4 minus x square, and x is between 0 and 2. And he said also check your answer by noting that the curve is part of a circle. Let's start with the second part. What the curve given is just part of a circle. It is just 1/4 of a circle. We complete it as a complete circle. This is a complete circle. And the circumference for the circle is given by, say, C is equal to 2 by R. Just 2 by R. And R is given by 2. So this is 2 by multiplied by 2 is equal to 4 by. This is the whole circle, but I need only this part, which is the one quarter of the circle. Now the arc length in this case is equal to 4 by divided by 4. That will give me 1 by. Now this will be the arc length for the given curve. But now I need to confirm it by using the arc length formula. We apply the arc length formula to confirm this answer. I need to confirm this one. So in the first step, I will find the derivative for the given function. Y prime is equal to, if we differentiate, I will get minus x divided by square root of 4 minus x squared. So the squaring of this one, y prime square, will give me x squared divided by 4 minus x squared. So the arc length, which is given by L, capital L, is equal to, it is between 0 and 2, the x coordinate, square root of 1 plus y prime square or f prime square dx, which is equal to 0 to 2, square root of 1 plus this one, which is x square, divided by 4 minus x square dx. Combine the fractions by finding the common denominator. I will have 4 minus x square plus x square divided by 4 minus x square dx. This will cancel this one. Square root of 4 will give me 2. So it is from 0 to 2. 2 divided by square root of 4 minus x square dx. Now by using the trigonometric substitution, we can let x to be 2 sine theta. So d theta will be 2 cosine theta d theta. So the arc length now in this case is equal to, from, I need to change the sign, I'm sorry, the limits when x equal to 0, I will have theta equal to 0, and when x equal to 2, replace x by 2, I will have pi over 2. When x equal to 2, I will have 2 equal to 2 sine theta. So sine theta equal to 1, which means that theta equal to pi over 2. Of the function 2, I will have 4 minus 4 sine square theta multiplied by dx equal to 2 cosine theta d theta. This also can be simplified as 0 pi over 2. This is 2. Down, I will take 4 as a common factor. And get it outside the square root, I will have 2 cosine theta. This is equal to 4 to the 1 minus sine square, which is equal to cosine square. So it is 2 cosine theta multiplied by cosine theta d theta. And you can see this. So cosine theta will cancel to cosine theta, so the remaining is 2. And integrating, I will have 2 theta between 0 and pi over 2, which is equal to 2 multiplied by pi over 2 minus 0. That will give me 1 pi. Next unit. If we go back to C, is it the same? Yes, you can see. We got pi there, and it is equal to pi using the arc length formula. Let's have another example. Let's find the arc length for this function. Y equal to x plus 4 to power 3 over 2, where x is between 0 and 4. So as we did in the first step, let's find y prime. That will be 3 over 2 multiplied by x plus 4 to power 1/2. Square it. Will give me 9 over 4 multiplied by x plus 4. So this 1/2 will be removed with the square. So the arc length now L equal to equal integration from 0 to 4 of square root of 1 plus y prime square dx, which is equal to integration from 0 to 4, 1 plus 9 over 4 multiplied by x plus 4 dx. Can open the bracket, I will have 0 to 4 square root of 1 plus 9 over 4x plus 9 dx. This is 4. 9 plus 1 is equal to 10, so this is equal to square root of 10 plus 9 over 4x dx, 0 to 4. This can be done by substitution. You can say that x equal to what is inside. Let's go step by step. Let 10 plus 9 4 over x, so du is equal to 9 over 4 dx, or dx equal to 4 over 9 du. And so we can change the limits for this case. When x equal to 0, I will have the limit is 10. When x equal to 4, I will have 19. This is just to change the limits, 0 and 4. Replace x by 0 and replace it by 4. So the integration now in this case will be L equal to from 10 to 19 of 4 over 9 u to the power 1/2 du, which is equal to 4 over 9 multiplied by 2 over 3 u 3 over 2 between 10 to 19, which that will give me 8 over 27 multiplied by 19 to power 3 over 2 minus 10 to power 3 over 2. Next unit. So this is the answer for this question, and this is the idea of how to find the arc length. This is just integration of square root of 1 plus y prime square dx. And if the function is written as x equal to g of y, then it is 1 plus g prime of y squared. we differentiate with respect to y. But since this function was given as a function of x, so it is 1 plus y prime square dx and integrated.